Namaste. So, in the last three, four videos, I talked about different programming paradigms from sequential programming or the procedural programming and to object oriented to concurrent and then event driven programming models. So, they provided very different types of abstractions reflecting the real world as closely as possible so that the task of converting it into a program that is executable by a machine becomes easier because it will naturally reflect what happens in the real world. All of these paradigms are revolving around the a notion of computing called the von-neumann computers. Von-neumann computers, basically there are two components. There's a computing component, the CPU, and there is a memory component. And there is a very relatively thin pipeline between the memory and the CPU. So, for you to perform an activity, you will need to bring something from the memory, store it in it, just perform an activity and store the result back there. So, and since this pipeline is relatively thin, the phrase got coined saying von-neumann bottleneck. So, because this became a bottleneck in speeding up computations, because it was like a lot of heavy traffic on a very narrow highway. So that's where people were trying to do parallelism, which allowed more pipelines to be set up, and so on. Much earlier than all this, there were other ways of looking at computing that was getting formed. So there were two, three of them that I will talk about. So the one that I'm going to choose today is called the logic based programming, or simply logic programming. So logic programming, as the name says, revolves around the notion of first order logic or predicate logic as the basis for expressing computation. So, as you might know, the predicate logic, with its universal quantifiers, existential quantifiers, and predicates, and common relationships like and, or, and not, is capable of capturing any kind of world description. Okay, at least theoretically, it can capture all of this. So, the core of predicate logic is a predicate, which is basically a relation like x likes y, or x is good at painting, or x is good at something, some activity. A is a multiple of b, and whatever. All of these things you can capture using these core predicates, and these predicates are interrelated using these other conjunct connectives like or and. So you can say that either x likes y or x's character is bad. So that is a disjunction, or I am rich and I am also intelligent. Okay, so you can have and. So all of that kind of common relationships can be captured using these connectives. So this was adequate language, and a couple of centuries back, people even talked about saying that all disputes can be resolved by capturing the essence through logical primitives and using logical inferences as the way to resolve them. So of course we haven't yet reached that level, but so the idea was that if that kind of richness is there, then logic or predicate logic can be used as a way to capture the world knowledge. Now, what it also meant is that this concept of a variable as a storage location which you can modify disappears, because now there are no real variables at all. So the variables are strictly scoped within the relationship. So I can say x likes y if x has if y has good character, or if y is rich, for example, right? And this x and y has no implications elsewhere. It's not a placeholder that you will modify. It is only to connect the precedent, the antecedent to the precedent. Okay, so I mean, listening to me just like this, you will not get a proper understanding of what this programming is about, or you can play it around. I have personally liked this idea of programming, and Prolog was one of my favorite programming languages. I did with one expert system shell. I did even a commercial project, using Prolog in my early days. Okay, so Prolog was kind of an exemplar language for logic-based programming. Now, when you want to do a programming on a artificial computer, and the computer is not a natural world representation. So when you want to communicate something to the computer, sometimes there are compromises to be done to this pure logic conventions. So these are also done. So there are some additional primitives for in-place computations. So like we want to say that something is a plus b into c. This is a little harder to capture it in a pure logic form. So these are computations, input output. These kind of things were introduced into the logic notation, which itself was captured in what is called a clausal form, and that is what is the Prolog's syntax is all about. So this had the advantage that I am nowhere am I going to talk about what to do first, what to do next, and what order you should do. It is all left to the system to do. So I am going to say that okay, here is my worldview. These are the predicates. These are the relationship. These are the rules that applies there. Now you tell me whether these two individuals are related by this or not. So this is done by what is called inferencing mechanism. Okay. So in logic, this is called a resolution. Okay, and you can look up some material on predicate logic to understand what these terminologies mean. So there are very well articulated, very mathematically sound mechanisms that is introduced for that. So through resolution, the system checks whether what you are asking for is a logical consequence of what is there in your specification. Okay. Now, how the system should go about it, what part it should do first, what it should do next is left to the system's own decision, and we are guaranteed that irrespective of the order in which this is done, your answer will not change. Okay, so which meant that these languages were considered as more amenable to parallelism or to formal verification and all that compared to this memory modification kind of languages, the von-neumann languages. Okay, so this was a very different way of looking at programming, and it takes some time for you to move from your favorite Java, C++ or whatever those languages into a logic based language. But you try it out. It is something that you will like once you get a hang of it. Okay, and it's not very difficult to learn. I think the entire manual, or so to say, would be possibly about 20 pages or something like that. Okay, because there is only core. I mean, even in the concept of assignment basically disappears because there are no variables to assign, and loops are basically recursion because that is the only loop structure that the logic supports. And so all that basically simplifies the language quite a large extent. So I enjoyed programming in Prolog, and there was also adaptations of Prolog to concurrent Prolog, Parlog, and all that, which brought in support for explicitly for parallelism. So this was actually interesting that we were not trying to incorporate parallelism into the language, but try to restrain parallelism. So which is because a logic language is inherently parallel. So when you put two relations, they can be executed in any order. But there are times when you want to say no, don't do that before this is completed. So these concurrent languages were basically mechanism to restrain saying what you should not do in parallel, and therefore make sure that you get meaningful output in respect of those compromises. It's a very interesting experience, and I think everybody should try it out and get a hang of it. It will actually give you a much wider sense of what programming is all about. So do try them out. I think there are still Prolog implementations available which you can download and play around with it. Okay, so take care and have a logical time ahead. And next one, I will talk about the functional programming as an abstraction or as a paradigm. Okay, take.